We're going to finish up talking about graphical transformations today. When you are combining transformations in a specific order, it says the graph of y equals x squared undergoes the following transformations in order. Find the equation of the graph that results. So first of all, you're going to have a horizontal shift of 2 to the right. That means in the square parentheses, 2 to the right means you're going to subtract 2. If you're going to do a vertical stretch, that's on the outside, so you put a 3 there, and then you're going to go up 5, which means you put a 5 on the end. And then you simplify it, 2 copies of x minus 2, so that you don't kill puppies, and that's going to be 3x minus 6 times x minus 2 plus 5. That's going to be 3x squared minus 6x plus 12 plus 5. Combine like terms, and I get 3x squared minus 12x plus 17. And that would be my simplified equation, transformation. Oh, I forgot I animated it. Okay, so if we do this one, we're gonna do the transformations in the opposite order. So if I have y equals x squared, to do a horizontal shift of 2 units to the right. Oh, I think we're going backwards. Okay, so we're going backwards. So I'm going to do 5 units up first. So I'm going to add 5 here. Okay, then it's going to say a vertical stretch by a factor of 3, which means we take the whole function and we multiply it by 3, which gives me, well, let's not do that yet. Okay, so then we want the horizontal shift of 2 to the right, which means in the square parentheses, we're going to go 2 units to the right, which would mean minus 2. So if I simplify that, this is going to be 2 copies. That's going to give me 3 times x squared minus 2x plus 4 plus 5. That's going to be x squared minus 4x plus 9. Then distribute the 3, and I get 3x squared minus 12x plus 27. So you can see we didn't get the same thing, which means the order does matter. Okay? Sorry, I animated this. Alright, so it says write a formula for the transformation of each graph. Solid is the original. So obviously the mother is the x squared function. This just went down 6. So subtract 6, not inside parentheses. This one, they turned it upside down, so you're going to have to multiply the square by a negative. And they went up 6 units, so that would be plus 6 on the end. Here, your mother function is the absolute value of x, and black is original, so dotted, all they did was went down 6, so my function would be the absolute value of x minus 6 on the outside. We're back to a mother function of x squared. They went left 6, which means inside my square, I'm going to go left 6, which means I add 6. Okay? Alright, so you figure out, here's the mother. They want you to go left 5 and up 3 and write the new rule. Hit pause, come back when you're ready. And hopefully you got 4. Okay, so if you're going to go left 5, that means inside the square you're going to add 5, and you're going to go up 3, which means you put plus 3 on the outside. So how do you translate the graphs of the functions? Well, again, describe these and these and these. Okay? Alright, so it says find the vertical stretch of the given function by a factor of 3. If you're doing a vertical stretch, that means the whole function gets multiplied by 3. So you put 3 on the outside of the whole function and then distribute it, which would give me 3x cubed minus 48x. Boom. I put the pictures on just to see, because you can see this is going to be some sort of a cubic function, which is this one. Okay, I typed that in for y1, and that's the graph. I showed you my windows so that you could see what window I typed to see it. And then for y2, I typed in that vertical stretch, which you can see if you vertically stretch it, you're pulling it out this way, which makes it higher and lower there. Okay, this one they want a horizontal compression. That means you're putting 1/2 of x inside the parentheses. So everywhere you see an x, you replace it with 1/2 x. Okay, you don't put the cube, I'm just replacing the x. So now when I cube that, I got to cube the 1, cube the 2, cube the x, I get 1/8 x cubed. If you distribute, 1/2 of 16 is -8x. And that would be my function. And again, I showed the picture. This is a horizontal compression. Okay, and again, you'd think that that would shrink it, but it's actually going to, see how you're doing a compression by a factor of 2? That would not be a compression in normal world, that would be a stretch, but it's it's horizontal, so it's opposite. So that's why we did 1/2 x and not 2x. So when you do a horizontal compression of 2, what it really does is it stretches this thing. Here's the original. It stretches this thing this way, which is why it makes it narrower. Okay? Alright, so they want you to find the vertical compression given a factor of 1/2. Well, this should have been by a factor of 2. They're telling you to replace it with 1/2. They should have used the wrong word. We'll put a 2 here, one or the other. Alright, so replace the x with 1/2 x and simplify. Hit pause, come back when you're ready. And you should get that one. So if I replace, oh, we're doing a vertical, my bad. Vertical is on the outside, which means you're taking 1/2 times the whole function. So you're doing 1/2 of x cubed minus 16x. So when I distribute that, I get 1/2 x cubed, and then 1/2 of -16x would be -8x. Okay? Alright, this one, here we go. This one they want a horizontal stretch by a factor of 4. If they want me to horizontally stretch it by a factor of 4, remember, we've got to do the opposite. So what we're finding is f of 1/4 x. So I replace the x's with 1/4 x. Cube the 1, cube the 4, cube the x. That's 1 over 64 x cubed. 1/4 of 16 is -4x. Sorry, I forgot to say hit pause. Okay, so there would be your function. Alright, so how do you stretch and shrink the graphs of multiplication? These are your rules. Okay? Alright, so graphing the absolute value compositions. It says, given the graph of y equals fx, the graph of the absolute value of the function can be obtained by reflecting the portion of the graph below the x-axis across the x-axis, leaving the portion above the x-axis unchanged. So, let's see. I don't know if this is going to work. Let's say that I do this. Okay? If I make that hard, if I'm taking the absolute value of that function, what it says is you take this portion below the x-axis and you reflect it up, which would be like that. Okay? If you take the absolute value, let me do my little graph again. If you do the absolute value of just x, it says you're going to replace the portion of the graph to the left of the y-axis. So you take this off and you reflect this side over, which would be like that. You kind of get the same thing back because I did an even function, but basically you take off the left side and then reflect this side over when the bars are on the inside. Alright, so it says the graph of f of x is shown. Okay, it's a parabola. It's not the mother function. That would be up here. Okay, This is the function. It says graph the given absolute value function. So if I take the absolute value of the whole thing, it says take this part and reflect it up. So I would come down like this and up like this, but instead of coming down, I reflect that up, which is going to look like that. Done. Okay, we got the same function, but now the bars are on the inside. The bars on the inside means that you take off the left side and replace it with the right side. So if I do this, I take off this side and I reflect this side, which would look like this. Oops, how about like that? Okay, so you kind of get this W looking thing. Alright, so on this one, they want you to take the absolute value of the function and then reflect it over x. Well, we already did the reflection, which looked like this, so now I have to reflect it over the x, which is going to come down like this, and then this is going to do this, come up like this, and back down. Okay, so it turns it upside down. This one, they want a double absolute value. You got to do the inside first. And the inside was take off the left and reflect it over y. Ugh. Hold on, I don't draw very well. There's the left or the right side. We're taking off the left side and we're reflecting the right. Change colors. So that would look like this, that W looking thing. Oops, it should come up like that. Ugh. Let me try this again. I don't draw very well. Alright, so it comes up like this. We're reflecting over. So it comes up like this. But now, we have to take the absolute value of all of that, which means we take the portion that's below and we draw it above, which means this is going to look like this and this is going to look like this, and you take off this part. Okay? Alright, the graph of the function f of x is shown at the right. Find and graph 2 times the function minus 1 plus 2. So what I did was I took these ordered pairs and I listed them in a table. Whatever's happening on the inside is happening to x, and whatever's on the outside is happening to y. It doesn't matter what order you do them in, as long as you do your x moves in ASPEDEP order and your y moves in PEMDAS order. So if I do this first, that says add 1 to the x's. And then I'm going to do, well, yeah, I should do that. So this then becomes 4, 0, 6, 3, 9, 4.5, and 10, 0. Which, if I write that in there, maybe I should do it down here. Alright. First of all, what we're going to do is we've already done this. So now we've got 2 things happening to y. When more than one thing is happening, order matters. So for y, you're going to do it in PEMDAS order, which means we multiply before we add. So first thing I'm going to do is multiply the y's by 2, which gives me 0, and 6, and 9, and 0. That takes care of that. Now I've got to do this, which means I add 2 to the y's. That gives me 2, 8, 11, and 2. So my new ordered pairs are 4, 2, 6, 8, 9, 11, and 10, 2. If I plot those points, 1, 2, 3, 4, 2, 5, 6, 3, 4, 5, 6, 7, 8, 7, 8, 9, 8, 9, 10, 11, 10, 2. And if I connect, then you can see it shifted to the right once, did a vertical stretch of 2, and then moved up 2. Okay? Alright, so if we do this one, it says find and graph f of 2x, which means we're doing a horizontal shrink of 1/2, which means we multiply the x's by 1/2. That gives me 1.50, 2.53, 4, 4.5, and 4.50. And those were the only transformations, so if I plot those, I'm going to have 1.50, 2.53, 4, 4.5, and 4.50. Bloop, bloop, bloop. Squishy. Alright, this one we have, again, two things happening to y, so we're going to multiply before we add, and one thing happening to x. Again, it doesn't matter what order you go in, I just like doing my x's first. So I'm going to add 1 to all my x's. That gives me 4, 0, 6, 3, 9, 4.5, and 10, 0. And that's done. Out of the 2 and the plus 3, I've got to do the multiply first. So I'm going to multiply my y's by 3, which gives me 0, 9, that's 4.5 times 3. Where am I here? 4.5 times 3. There it is. It's 13.5. And 0 times 3 is 0. That's done. And now I'm going to add 2 to my y's. So plus 2, plus 2, plus 2, plus 2. That gives me 2. That gives me 11. That gives me 15.5. And that gives me 2. So my new ordered pairs are 4, 2, 6, 11, 9, 15.5, and 10, 2. So if I plot those, 1, 2, 3, 4, 2, 5, 6, 3, 4, 5, 6, 7, 8, 9, 10, 11, 6, 7, 8, 9, 11, 12, 13, 14, 15.5, and 10, 2. So if I connect those, bloop, bloop, bloop. Okay. Alright, this one we have one thing happening to x and two things happening to y. Multiply by a -1, add 1, and this is going to be subtract 1. I'm going to do my x's first. So I'm going to minus 1, minus 1, minus 1, minus 1. That gives me 2, 0, 4, 3, 7, 4.5, and 8, 0. Okay, then I'm going to do my two, hold on. I'm going to do my two y moves. I got to multiply first, so times -1, times -1, times -1, times -1. That gives me 0, -3, -4.5, 0. That's done. So now I have to add 1 to my y's. If I add 1, add 1, add 1, add 1, I get 1, 4, try again, -2, -3.5, and 1. So my ordered pairs are 2, 1, 4, -2, 7, -3.5, and 8, 1. So if I plot those ordered pairs, I'm going to have 2, 1, 4, -2, 5, 6, 7, -1, 2, 3.5, and 8, 1. And there we go. Okay? Alright, it says the graph shows the projected altitude f of x in thousands of feet of an airplane scheduled to depart an airport at noon. If the plane leaves 2 hours late, what function represents this transformation? Hit pause, come back when you're ready. And you should get 4. If your graph is this one and you're going to leave 2 hours later, that means you need to shift it over 2 units this way. Okay, which would be out of these two. Well, if you're going to go 2 left, you wouldn't add 2 to the function. You would subtract 2 from the function. So it's got to be 4. Alright. And we are done. So happy homeworking, and I will see you next time.